Let's say that we have a street in here in which there are a couple of houses. Also, there is another street in here which you see, and there is 4 different houses in this street too. Now let's say that we want to create a mailing scheme in which, or a numbering scheme in which every house has a complete unique address. But all the numbers that we could work with are numbers of 1, 2, 3, 4, 5, and 6. So because we only have 6 numbers and the numbers of all these houses are more than 6, we need to create another scheme. First, what we are going to do is to give all of these houses the number of 1, 2, 3, and 4, and also for this second street. No 2 houses in the same street should have the same numbers. We are left with 2 more numbers, 5 and 6. We assign the 5 to this street and 6 for this one. Also, we assign 2 mailmen for each street. Now, any one of these houses in the same street, when they want to communicate with each other and mail information to each other, they would give the mail to the mailman. Now, when the mailman in each street sees a mail with the source or destination address of 1, 2, or 3, and 4, it knows that the destination is in the same street. So, for example, if the destination is 3 and the source is 2, it knows that the mail has originated from 2 and should be delivered to 3. Also, the same scheme works with the second street in here. Now let's say that the house number 2 in this street wants to send a mail to the house number 3 in the second street. In this case, the destination should be the street number 6 and the house number 3, for example. So when this mail is delivered to this mailman, because the destination address is 5 or 6, which is considered to be a public address, it knows that it belongs to another street or network. So it would deliver it to the other mailman, and he in here would deliver it to the correct house in here. In this case, if we have more streets, like for example 3, the only other number that we need to create the numbering scheme to work for all of them is 7. So you see, in this case, we would assign the number 7 for this second street, and so we have 12 different houses with only 7 numbers. Also, we could do the 24 different houses using only 8. In this example, numbers 1, 2, 3, and 4 are the examples for private IP addresses, while the number 5, 6, and 7 is an example of public IP address. All the mails that has the source or destination address of 1, 2, 3, or 4, or a private address that is only routable for the inside street or inside network communication. Any mail that has a private IP address for its destination address cannot be directed outside that street or network. So in this case, we say that the private addresses of 1, 2, 3, and 4 are non-routable, or are for inside the network communication. As the same thing applies to the computer world. In this example, for example, let's say that we have 2 networks in here, and we know that for communication, every device should have a private IP address. So we assign these IP addresses, these private IP addresses, which are in this range in here, which we talk about, in this third range in here, we assign these IP addresses to all these devices. 192.168.1.2 would be for this device, 192.168.1.1 would be for router, and as you see, the other ones. We assign the same numbers for all different devices in the second network too. Now, the router is acting as the mailman. Whenever it sees a packet which has the destination address which is in the private range, it knows that it belongs in the same network. For example, let's say that it receives a packet with a destination address of 192.168.1.4, so it would just deliver it to this device. The same thing happens to the other network. So for the inside local area network communication, the private IP addresses are suffice. But if they want to communicate with each other, we need to assign them a public IP address. So let's say that we assign the public IP address of 5.5.5.5 to this network while it is actually assigned to the router. The router has 2 NICs, which we talk about in the next lectures, and then we assign the IP of 4.4.4.4 to the other router. These public IP addresses are assigned to each router or each network by the internet service provider of the same network. Now, in this case, whenever any device in here wants to communicate to another device in this network, it cannot put a private IP address. Let's say that the device with the IP of 192.168.1.3 wants to send some data to the device of 192.168.1.2. If it puts the destination address in the packet equal to 192.168.1.2, when it gets to the router, it just forwarded to the device in the same network with the IP address, which is this device. In order for this device to send packet and data to the device in the other network, it needs to provide the public IP address of the second network in here. So the destination IP address in the packet would be equal to 4.4.4.4. Nowadays, most connections are server-based. What we mean by server-based is that in each communication, one of the 2 devices would act as a server listening to a specific port number. For example, in this case, the 192.168.1.2 might be a server which is listening at a specific port number, for example, 80. Now, 192.168.1.3 already knows that this device, this phone in here, is acting as a web server listening to a specific port number equal to 80. So it would put the port number of 80 as the destination port number. When it gets to the router, the packet gets to this router in this network, it looks at all the devices in here, sees that the only device which is listening at the port number 80 is the device with the IP of 192.168.1.2, so it would forward the packet to this device in here. It is this process that I just introduced to you is called NAT or network address translation or port address translation. But the goal of this lecture was to give you a simulation between 2 separate networking mechanisms, one of them in the real world and the other in the computer world. So, and again, for the summary of this lecture, we could say that every one of these devices is like every house in these examples, and the router in here would act as a mailman. And the street in here is somehow representing the network in the computer world.